During the industrial age, engineers pushed the limits of metal, motion, and precision in ways the modern world still struggles to understand. Factories roared. Workshops glowed. And craftsmen worked by instinct, not formulas, shaping machines that defied the technology of their time. But hidden among the millions of devices created during that era, there exists a select few that stand apart. Machines so perfectly built, so flawlessly balanced, that even with CNC tools, computer simulations, and high-grade alloys, modern engineers cannot recreate them. Today, we uncover 5 industrial-age inventions no one has been able to rebuild. Not because the blueprints are lost. Not because the materials no longer exist. But because the knowledge, the touch, the mastery disappeared with the hands that created them. Number 1, the Heidenhoff microtolerance gear set. Found inside an abandoned Bavarian mill. This small gear assembly was initially mistaken for a prototype clock. But closer inspection revealed something far more extraordinary. The gear teeth maintain tolerances under 10 microns. Achieved without any modern machining. The gears mesh with absolute smoothness. With no detectable vibration. Modern CNC replicas attempt to match the tolerances, and fail. Even tiny deviations cause chatter or misalignment. The original? Silent. Perfect. Untouched by time. Researchers believe the maker used a hand-guided process. Listening to the pitch of the gears. Adjusting by ear rather than instrument. A human method no computer can simulate. Number 2, the Marwick self-balancing flywheel. Deep in the basement of an old textile factory, investigators found a flywheel mounted on a cracked oak bench. It looked ordinary. But when lightly spun, it rotated for nearly 20 minutes with no visible wobble. The flywheel's internal mass distribution is so perfectly balanced that modern engineers still debate how it was achieved. Laser scans show microscopic asymmetries. As if intentional. Designed to self-correct motion. Attempts to reproduce it on modern machinery result in vibration, skew, or premature deceleration. The original maintains centrifugal harmony that seems almost impossible. Some believe the craftsman carved it while it was already spinning, letting motion guide the material removal. Others think he used a forgotten technique of incremental counterweighting. Either way, no replica performs like the original. Number 3, the Hartwell steam pulse regulator. Discovered in a scrapyard. This brass and iron regulator once controlled pressure in early steam engines. But unlike modern systems that require precise valves and sensors, the Hartwell regulator responds to pressure changes with near biological precision. Its internal chambers are shaped in a way modern computers cannot fully model. Tiny cavities, smooth transitions, and curved pathways that redirect steam with almost no turbulence. When engineers attempted to rebuild it, the replicas either produced violent pressure spikes or failed to maintain stable output. The original device, however, managed steam flow so smoothly that early operators claimed it breathed. Its design appears intuitive, not mathematical. A shape discovered through experience, not calculation. Number 4, the Ellington compound slide engraver. In the ruins of a burned woodworking shop, archaeologists found a partially preserved engraving machine unlike anything in modern catalogs. It uses 3 sliding axes connected by a system of brass couplers that convert motion into patterns far more complex than simple gears or cams could produce. With only a hand crank, the machine engraved looping curves, mathematical spirals, and interlocking patterns with a precision modern engravers struggle to match. When craftsmen today attempt to replicate the machine, their versions bind, skip, or lose synchronization. The geometry of Ellington's couplers is so precise That even tiny imperfections cause the mechanism to seize. The original machine still glides smoothly. As if the metal itself remembers how to move. Number 5, the Holloway variable pitch cutting head. In an abandoned metalworks outside Manchester, a strange tool head was found inside a locked drawer. The only piece that survived a fire over a century ago. At first glance, it looked like a multi-tooth cutting bit. But when examined closely, the teeth shift pitch subtly along the circumference. This allows the tool to cut metal with almost zero chatter. No matter the speed. The effect is so smooth that even modern carbide tools struggle to match it. The mystery? The transition between tooth pitches is continuous. Not stepped. Almost organic. Modern cutting heads require extremely precise grinding wheels or CNC interpolation to achieve similar effects. But the Holloway head shows no tool marks. No grinding patterns. No machining signatures. It was shaped by hand. With a level of precision modern machinists cannot explain. Looking at all 5 inventions together, a pattern becomes clear. These were not anomalies. They were masterpieces. Born in workshops where metal was shaped by ear. By touch. By instinct. Where craftsmen felt vibration through the tool body. Adjusted pressure by intuition. And carved geometry not from calculations, but from experience. Machines we can measure. Machines we can diagram. Machines we can simulate. But machines we still cannot rebuild. Because the industrial age wasn't only about steam and steel. It was about the craftsmen. Men who understood materials in ways the modern world has forgotten. Their knowledge didn't disappear because it was wrong. It disappeared because it was personal. Living inside the hands of a generation that left no written record. And the most advanced inventions of that era still sit in dark museum corners. Abandoned factories. And private collections. Waiting silently. For someone to rediscover the mastery behind them. Knowledge lost. And knowledge still waiting to return.